And now I'd like to welcome Alan Eustace and Vint Cerf for their conversation about internet trends. So Vince, Alan, come on up.
Thank you. Well, good afternoon, everyone. I'm Vint Cerf, and I hope you've all come back from a pleasant respite, a chance to chat, maybe bump into some of our executives over lunch.
And just in case nobody recognizes me, I'm Alan Eustace. This is the first time I've ever worn a suit on Google property, and I did it in honor of Vint Cerf, who always sets a very high standard of dress at the company.
This, has always been my hope to raise the sartorial quotient of the company. I knew that I'd raised the age of the company when I joined it, but the sartorial quotient has stayed kind of stable, so thank you very much.
I did my best.
I confess to you that I feel always relief when I walk out here in the quadrangle and I see that dinosaur out there, because at least there's one dinosaur older than I am that's on this campus. Well, let's start out by having a look at the statistics of the net over the last 10 years. If we were here 10 years ago, I would have been fulminating about 50 million users. Now there's more than 1.2 billion users on the network today, and over 489 million servers on the net. That doesn't count laptops, desktops, PDAs, and things like that, which are episodically connected to the net. These things are online all the time with domain names and IP addresses that are firmly fixed. There are on the order of 3 billion mobiles in use today. Now, not all of the mobiles are internet enabled, but in fact, many of them are, and many more of them will be on a percentage basis as time goes on. This is really important to Google and to anyone that's offering internet-based services, because more and more of the world's population will be first introduced to the internet by way of a mobile. And you can imagine all the challenges associated with that, the bandwidths that are available, the screen sizes that are available, the kinds of keyboards and interactive mechanisms that are available are all constraining. And so you have to reinvent the way in which you interface with users and the way in which you present information in order to allow them to make effective use of the services that you have by way of mobiles. It's very valuable to look at how the internet's user space is distributed. And what you're seeing here is that Asia is now the absolute largest fraction of internet users in the world. Now, Asia, of course, covers a lot of territory. It includes India, China, Malaysia, Indonesia, Japan, and so on. The point here is that it's only that area, with its almost 500 million users, 460 million users, is only 12.4% penetrated by population. This can only go up. There are implications in all of that, primarily that the interests, the languages, the culture, the applications of internet are going to be strongly influenced by our Asian colleagues as more and more of them become part of the internet environment. And I wanted to ask Alan about two things. One is that this distribution puts challenges in the front of Google, because we clearly have to be a global company addressing global needs. And second, the scaling factor is pretty daunting. 1.2 billion people is only about less than 20% of the world's population. If this continues to grow, we're going to have to meet the demand of users on a scale unprecedented. How are we doing?
So we're doing pretty well. The main thing for me about this graph is that we came to the conclusion a long time ago that we can't meet the needs of the world's internet population with engineers just in Mountain View, California. And so you probably have had a scattered inkling of our efforts to build a global organization. Now we have probably 40 locations around the world. About half or more of those are in places like China, Japan, Poland, Zurich, China, India, and these are not situations where we're trying to outsource, engineering. We still believe that engineering is a critical part of the company. We're a technical company. We're going to solve these technical challenges with engineers, but we're able to attract some of the best and most talented engineers around the world to solve first-class problems. And I think what this graph is really a recipe for how engineering resources should be distributed in some sense, and how we should be thinking about problems that are outside of Mountain View, outside of English. We were one of the first companies to actually internationalize our search page to a huge number of countries. I think it might be over 120 languages at this point. And if you want to know one thing about how we're attacking the world's problems, you should look at this graph, because this is a map of of the markets that we're going to have to go after in the next 2 or 3 years.
So another thing to observe here is that the penetration levels are quite varied from region to region. And of course, from country to country, it's even more dramatic. The point that I want to make here is that these populations that are penetrated at low percentages are going to be approaching the internet in one way, where not necessarily a large number of people, colleagues and so on, are all online at the same time. So the critical masses are different. In North America, where it's 70% penetrated, it's hard to imagine doing anything without having access to the internet today. So we're going to see shifts as the percentages go up in the way people want to use the network and the way in which they contribute and access information. I thought you'd be amused to see what the predecessor to the internet looked like in 1969. There were only 4 nodes. One of them was up in the SRI, at SRI International. And I was a graduate student at UCLA in September of 1969 when the first node at UCLA was installed. I wrote the software for the Sigma 7 computer to connect the first node to the ARPANET. The Sigma 7 is now in a museum, and some people have suggested that I should be there along with it. If you fast forward, though, 30 years, the internet looks like this. It becomes vastly more connected, vastly larger, and more colorful. And I think that's about as good a definition of internet as anybody has come up with.
The one thing I'll say about this slide here is that we have to keep pace with the information generation that's happening around the world. If we're going to organize and make accessible all the world's information, this graph says how complicated that job is, because the information is now distributed worldwide in lots of different areas. It's different types of information. It's video information, it's text information, it's websites, it's news, all the different formats of information. And this graph gives you an idea of just how distributed that is. And if we had another one that had languages, you would see from a language point of view, it's actually very distributed across the world. So this gives you a flavor for why it's so important to build up computational infrastructure and other things. Because just crawling the web right now is becoming more and more difficult. There's more and more sites that you have to visit. There's more and more good content out there. And especially if you look at geographic regions like China, we have to consciously go after information in China because it's not quite as connected, especially to the US, and therefore we have to make aggressive plays to get information outside the United States. And so this is an example of how complicated that task is.
So let's see what it is that's driving everything. Some of you may have seen this that magazine cover. When the internet was first designed, Bob Kahn and I knew ahead of time that we didn't know what new transmission and switching systems were going to come along. And so we said we better design it so it's pretty insensitive to the underlying switching and transmission technology. So I had a t-shirt made that says IP on everything. And that's basically what I've been doing for the last 35 years, is trying to get the internet protocol to run on virtually any transmission and switching system. And by and large, that seems to have worked. Even as mobiles have come along, we found ways of making them fully internet enabled. What's also important is that the packets of the internet don't know what they're carrying. They have absolutely no idea. The network is completely application insensitive. And as a consequence, if you want to invent a new application, you just do it at the edges of the net. You don't have to get permission from anybody, at least up until now, to do that. So when Larry and Sergey started Google, they didn't have to get permission from an ISP. They didn't have to go and talk to people all around the world. They just put the servers up and said, have at it. That has been the engine of innovation for the internet, and it's important to preserve that openness and neutrality of the network. And so this is something that you'll hear us talk about a lot. The end-to-end principle says all the interesting stuff happens at the edges of the net. Computing in the cloud is another example of the power of the edge of the net and the transparency of the network to interaction.
And this is a good time, by the way, to thank our friend Vint here for the early decisions, for many of the early decisions that had to do with the internet. He obviously didn't do it all. You know, he was in there very early. But there was a set of very key decisions that were made earlier having to do with trying to separate out the physical medium from the transition, trying to separate out data from the transmission mechanisms, allowing multiple ways to get to his site, and those principles and the fight for those principles Vint has spent his entire life on. And I think much of the success of the internet is based on those principles. And so this is a good time to thank you. I really appreciate all you've done for us.
Thank you. I think the real answer is that I don't think we could have figured out how to do it any other way. I mean, in some ways, this problem was so self-defining that many of these principles emerged as the most obvious and easy way of trying to get the system to function. So let's look at what's actually happening. Some of what you've been talking about, some of what you've heard this morning is related here as well. But the thing that has struck me anyway over the last, let's say, 5 or 6 years, is that all of the people who have been consuming information on the net are now producing it. And it manifests itself as blogging and YouTube uploads and the personal web pages and all kinds of social networking mechanisms as well. The network has dropped the barrier to contribution to essentially zero. And I think the most dramatic way of suggesting this to you is to imagine that you're looking at a Wikipedia page and you're looking at a paragraph in the Wikipedia and you see one word which is wrong, and you know it's wrong because you're an expert. You can actually go and change that one word. Now, you'd never publish a one-word book, and you wouldn't publish a one-word scholarly paper, but you can inject one word into the internet and make a significant contribution. Of course, you could publish a paper or a book or a movie or a web page or anything else. The network has no barrier to contributions, and it has opened up a spectrum of opportunity for people to share information in ways they never could before. Social networking came up earlier in the discussions that you had this morning, so I won't emphasize it any more than to say it is a very important organizing principle. Space is an organizing principle, and you see it showing up in Google Earth. Time is an organizing principle. You see it showing up especially in email and things like that. Your social network is another organizing principle, the world of information surrounding you, your friends and your colleagues and your family. And we're seeing all three of those organizing principles representing big opportunities for Google to present relevant information to people who are using the system. The game playing is not new, although I have to say the scale is something that is new. I don't think we've ever seen games played by millions of people at the same time. But Second Life and World of Warcraft and others like that, EverQuest and so on, are extremely popular. And we're now starting to see some very surprising advertising opportunities showing up in these virtual worlds. Now, I'm just an engineer. It never would have occurred to me that it made any sense at all to advertise in a virtual space like Second Life. In fact, it turns out if you're participating in it, you know how you create these avatars. And some of them don't look all that good. It turns out you can hire people and pay them real money to make your avatar look better. And so there's actually a business to be had in making people's avatars look a little more elegant than the one I picked anyway. So there are opportunities in that direction. There's also opportunities to bring to attention in the virtual world things that are going on in the real world. And we see it in other media. You see books advertised on television. You see magazines on the radio. You see newspapers advertising movies. All of these various media are mutually reinforcing, and we're just seeing another opportunity here. The last point I want to make on this slide is that the economics of digital everything are driving new business models, and it's very dramatic. So if you think about it for a minute, just to dramatize the digital cost of everything, in 1979, a few months ago, I bought 2 terabytes of disk storage to use at home. It cost me about $600. In 1979, I bought 10 megabytes of disk storage. It was the size of a shoebox. And I was pretty excited about having 10 megabytes of disk storage available. It cost me $1,000. And I got to thinking the other day, what would have happened if I tried to buy a terabyte of disk storage in 1979? And if you do the arithmetic, it would have been $100 million. Now, I didn't have $100 million back in 1979. And, to be honest, I don't have $100 million now either. But if I had had $100 million in 1979, I'm pretty sure my wife wouldn't let me spend it on disk storage. She would have had another idea. The same kind of statistics show up for storage, processing, and transmission of digital information. And old business models that relied on older economic models of information and older media, paper, 35 millimeter film, and the like, have to change. Darwin was right. You only have 2 choices, adapt or die. And so companies are going to have to adapt to the new reality of digital economics. And I assume that we've taken advantage of that. Otherwise, we couldn't operate at the scale that we do.
We definitely have benefited from the new business models. The other thing I wanted to say on the information just in general
Can we go back a couple of slides? You're not going in the direction I'm clicking. That's important. Thank you. Okay.
So the other thing is, it doesn't come across in this so much, but if you look at the rate at which changes are happening on the internet, they're happening much faster. If you look at, for instance, the update of our index, you know, it used to be fine to update your index every 30 days. And this isn't that long ago, you know, 4 or 5 years ago. It was fine. And you would just assume that if you wanted to find something recent, you know, you would look in, you know, a newspaper or something like that. But one of the socioeconomic effects of the internet actually has to do with the rate at which our expectations and data change. And so we want to get to the point where the freshness of the data on the internet is as fresh as anywhere other medium. And there's no reason we can't do that. Actually, we're very strong right now. If you look at, you know, from the time that something goes up on the internet to the time that that becomes indexed right now, in a large number of cases, we're really pushing the boundaries there, you know, seconds and minutes to get something on. And I think that's an example of how, even though outwardly the technology really doesn't look like it's changed, what we're actually seeing is much fresher information to users. And I think it's an important distinction. And one of the reasons why it's not sufficient to have what you might think of as batch processing. You know, batch processing went out a long time ago. But on the internet, we need to be looking at information as an immediate concern and not something that can be done over long term. So it's having an effect on the way we design systems.
Okay, many of you are, I'm sure, hearing about IPTV, and an awful lot of people think immediately of streaming video. And I would like to suggest to you that that is an overly narrow view. Here's why. Some of you use iPods, or maybe your kids do, and one thing you should notice is they download music faster than they can listen to it. I mean, literally, the data rates are high enough to download music faster than real time. When we get to high enough data rates in the internet, you can download video faster than real time. And in fact, if you've ever watched a YouTube download, you'll notice that the little bar that's downloading is actually loading faster than you're watching it. So we're actually already in the YouTube era seeing data rates that are in excess of the need to watch it in real time. I think that this translates into some very interesting new kinds of behaviors. I believe that it will be very common for people to download video and play it back later on, in the same way that they do with personal video recorders on cable systems and the like, or maybe on satellite television. More importantly, the internet doesn't really care what it's carrying, so it's not limited to video and audio. When we're downloading stuff, we can download virtually anything. So if we are downloading a video movie, for instance, there's nothing stopping us from downloading not only the movie, but the book that goes along with it, the biography of all the actors and actresses, the story about how the movie was being made, advertising material that might be relevant and related to the movie, or may be related to the party that's downloading it, if we know either who they are or where they are or what time it is when they're downloading it. In fact, because the instrument that is going to be rendering this movie is programmable, it suddenly is a lot smarter than a dumb raster scan display. It's a programmable device. So now I want you to imagine for a moment that you've taken the opportunity, or someone has taken the opportunity to do product placement in the movie. So there are products like these two IBM ThinkPads, maybe a Macintosh somewhere, an automobile and the like. You can sensitize the digital image of those things in the screen, and you could mouse over them, highlight them, and click on them if you wanted to. And when you click on them, a little window opens up and it says, I see you're very interested in this Mercedes-Benz that you saw in the image. Let me tell you a little more about the car. If you happen to be online at the time, we could actually reach out into the net in real time, pull back information like there are 6 of these in inventory in Joe's Mercedes-Benz dealership down the street. You could be much more active about your interest in and interacting with information that's associated with this particular movie. So what's critical here is that we're trying to, I'm sorry, don't let me mislead you. We are not doing this. This is Vint Cerf speculating about things you could do. But what I would see as an opportunity is creating an interactive experience for advertising in this particular medium, which is quite different from the traditional one, which interrupts everything, forces you to watch a video of some sort for advertising purposes, and then goes back to the action. So here, I think it's technically possible to create a whole new range of advertising experience for consumers if, in fact, they download this variety of information digitally and then play it back. What's also important is that the data rates that we can sustain at the edges of the net go all the way up to a gigabit per second or more. And there are some parts of the world where you can get a gigabit per second access to the internet. In Tokyo and Kyoto, you can pay about 8,700 yen a month for a gigabit per second access. So you can download an hour's worth of video in about 16 seconds. So video on demand is no longer watching real-time video. And if you happen to have a slower connection, there's nothing stopping you from downloading this stuff as file transfers at a lower data rate and then playing it back later on. So the idea here is that you can increase the kinds of advertising interactions that users can have in this particular medium thanks to the data rates and the inexpensive storage technologies that are available today. I don't know whether that triggers anything from your point of view.
No, we should keep moving through your slides.
We've already talked a lot about mobiles.
I'm sure they have a question or two they want to ask.
Okay. Well, we're coming up to finishing up here. Actually, that 2.5 billion should probably read 3 billion mobiles now. But these devices are not just telephones, right? They're programmable devices. It would be nice if you could download new applications. It's something that we've been advocating. But you can virtually do a lot of different things with these devices beyond what a telephone can do. Some of them are being used for making payments. Some of them are being used to play games. Some of them are being used to access web maps and things of that kind. In fact, we're seeing more and more interest in geographically indexed information because people are carrying their information appliances on their hips or in their purses, and the questions that they have often are related to where they are right now. So the value of geographically indexed information has gone up, and monetizing that is something that we have an opportunity, and others as well, to do. Sir, I think we have a couple more. If you're like me, you've been a little stunned at the devices that are showing up on the net, like internet-enabled refrigerators, internet-enabled picture frames. I mean, come on. First time I heard that, I thought, boy, that sounds about as useful as an electric fork. But, but in fact, these things download images from web pages and then play them. And it's wonderful for the grandchildren or grandparents, right? They don't have to boot up Windows or do anything else. They just turn it on and it downloads images and plays them, and it gets new instructions from time to time. But the guy in the middle is the one that amazed me. He has an internet-enabled surfboard. It's a product. He's from San Diego. He was sitting out there waiting on the water thinking, you know, if I had a laptop and a Wi-Fi on my surfboard, I could surf the internet while I'm waiting to surf the next wave. And he did it. He built this thing, put a Wi-Fi transceiver in the rescue shack back on the beach, and he sells this as a product. So if you're interested in internet-enabled surfboards, here's the place to go.
And it'll create a secondary market for bosses that need to track where their employees are actually getting work done.
I think there are going to be billions of devices on the internet, many more devices than there are people. They'll be interacting with each other. They'll be supplying data. It could be your automobile that's been instrumented. It could be the house that's been instrumented for the HVAC and all the other kinds of things, the security and everything else. So we're going to see more and more of these things out there on the net generating information. And finally, this is, warning, this is not Google's business plan. We are not planning to take over the solar system. This is simply a project that I've been working on at the Jet Propulsion Lab for the last 8-9 years now. We're simply standardizing communications protocols in space, and the purpose for that is to create the possibility of an interplanetary backbone accumulating as we launch new missions into the solar system, because each time we launch a new mission, some of the previous mission assets may still be there, and we could use them if we have standards that can support the communication. Just like when you plug into the internet, you can talk to 500 million other machines because of the standardization. So that's the up-to-the-date report on interplanetary internet, and I think we're going to end up with an interplanetary backbone over 20, 30, 40 years of time as these missions get launched and as they persist in their missions. The example of long missions, the 2 rovers on Mars have been running for over 4 years, and they were expected to last 90 days. So that's something to look forward to, is data coming back from space, which will help to organize, just like we have everything else. Mr. Eustace, do you have anything to add to this?
No, sir, I do not.
Okay, in that case, let's turn this over to our friends in the audience with questions that they may have.
You've been pretty active when it comes to net neutrality, a lot of the telecom stuff that's been going on, and particularly I know even 700 megahertz has gotten your attention. How important is the 700 megahertz for Google going forward? And is Google going to be in a position, no matter what gets codified by Kevin Martin, to not actually bid to win? Can you just talk a little bit about 700 megahertz?
Okay. First observation to make is that the spectrum is of interest in part because it's a potential alternative channel to reach consumers other than the ones that exist today. On the other hand, we have to make everything work through all the existing communications media because that's how you reach people. So this doesn't mean that we've abandoned our interest in all the other ways of reaching everyone, whether it's through mobiles or through the conventional cable and DSL systems. I'm not party to any specific plans yet for what would we do if we actually got that spectrum. I think we're still looking at what the various opportunities might be. But we believe strongly that there should be an alternative, and you could tell from what we've asked the FCC that we're interested in the shape and rules for access and use of that spectrum, which is why we push so hard for the openness principles. The 4 that we suggested, of the 4, 2 were made available. So this is still a work in progress, to be quite honest with you, but we have made a commitment that we will be prepared to put up to the reserve price on that spectrum at the time of the auction.
I mean, the main thing is if you want to change, an industry in some sense, if you want to make things available to people, you can talk about it. You can work with the FCC. You can do all kinds of things, but it's also important to put our money where our mouth is at particular times and particular places where it makes business sense for us to do. So I feel like we as a company, it's important that we really work to make the mobile system as useful and as expandable and as from a economic point of view, a driver, the way that the internet has been a driver for us. And I think it's important for us to participate in all those conversations. And I think this is a great forum for us to do that. Obviously, we're not going to talk about what we're going to do, why we're going to do it, things like that. But I think the overriding thing is this is an industry that I think really could dramatically improve their ability to make internet-like decisions and internet application delivery mechanisms really work. And so we're going to work on trying to participate in that process.
So we have some microphones here. There's a gentleman over here with a microphone.
Ben Schachter, UBS. You've both spent a lot of time throughout your careers working to build the internet and keep it open, and you've also spent time recently dealing with some of the political aspects of it and the regulatory aspects of it. How do you think Google can best promote keeping a lot of the things that made the internet what it is today going forward, both in the U.S. and also the complications as it does expand internationally with different types of governments? And really, what is Google's role in that, and how do you fit in there? Thanks.
Okay, well, Google, as you know, has assembled a fairly powerful team of people in Washington to deal with policy matters that affect us in the United States. And some of you may know that the amazing title I was given when I came here is Chief Internet Evangelist. And I'm not wearing my ecclesiastical robes. I'm just in my, everyday three-piece suit. But I do spend a lot of time dealing with policy questions on a global basis, country by country, talking to people who are responsible for various aspects of policy that affect us in our business. The European Union, the European Commission, is very active, as you know, in these areas. Vivian Reding, in particular, is quite interested in policy with regard to openness of broadband resources and creating of competitive environments. So Google has worked very hard. Andrew McLaughlin is our chief of policy, worked very hard to put in place voices from Google and voices from others who see the things as we do to try to encourage exactly this kind of open environment where competition and innovation are rewarded and, in fact, supported. It's sometimes an uphill battle, but I think the history of internet itself makes for a pretty compelling argument that keeping things open and making innovation possible is the best possible way of increasing the economic value of this whole system. And so that's the message that we try to deliver on a regular basis wherever I happen to be and where my colleagues are as well. Okay. So this is great. We have twin microphones arriving for two different people. This gentleman got his first. Go for it.
Thank you, Eustace Scully at Jefferies. Comcast admitted yesterday to actually delaying some subscriber P2P traffic. How serious is that? And I guess how much of a threat is that to the health of the internet as a whole? And if they do get away with it, will that push others to kind of follow suit? Thanks.
It was actually quite a surprising admission by Comcast that they had been altering the packets that were flowing through the net, in some cases responding on behalf of servers that they had intercepted. This was pretty surprising, and I don't understand all of the motivations. I don't know if they've been too open about why they did this, as much as simply saying that they did what they did. I would, on a charitable face on this, is to say that this is an example of a company that's trying to struggle to find how to adjust its business models to meet with the kinds of demands that are showing up in the internet. It's another example of how you have to adapt. On the other hand, it is for precisely this reason, this kind of example, that Google was so vocal about wanting to say that those who control the underlying capacity should not therefore abuse that control to influence higher levels of applications possibly coming from competitors. And so, if anything, this is going to be a really important test case to understand what posture our regulatory system is going to take, or perhaps even our judiciary system if we see this as anti-competitive. If for some reason it is thought to be perfectly okay for them to do that, I consider that to be a serious blow to internet in the United States, because it will begin to impair the opportunity for innovation, the permissionless ability to try new things out and to deliver them to people who are interested. So I honestly hope that that particular behavior will be considered inappropriate and proper actions taken to inhibit it in the future. Yes, sir.
Natural search inevitably drove the cost of changed the rules on the cost of distribution. The ability to get distribution from Google or Yahoo and others basically went to zero. And Facebook has sort of rewritten the rules on the cost of distribution again in terms of their ability to automatically communicate to a network of people the activity that I'm doing. So if I join a new friend, I use I use any of their applications, it drives virally the application adoption throughout the network of my friends. When I'm on iGoogle, I don't have that ability to know what other people are doing to drive the adoption of the applications they're using and vice versa. It seems that increasingly is an important imperative, and you've actually adopted on YouTube. You show on the top of the page now what videos are being shown. What's the technology limitation, Alan, that's not allowing you to do that social communication on iGoogle?
Okay, let me just respond by saying you and I resonate on this point. This is the organizing principle that things are organized around what your friends are doing. So I'm a big fan of trying to make things happen that way. Did you notice in the demonstration for iGoogle this morning that the gadgets were interacting with each other? I don't know if you caught that. That basic mechanism could conceivably be used to do some of the things that you're alluding to here. But I'm going to turn to Alan, who is responsible for the engineering side of things, to see whether or not you feel that we have enough mechanism in place that we could explore that space.
Well, I think it's a really important space. It's a really important comment, is that interconnections between people and communication in general are a really important way that information is actually cycling right now. And if you look at the over time, what's happened to Google, before Google, you would type in something and you would get a result if you asked for it, kind of thing. And you'll see more and more cases right now in desktop search where we're, and other things, in Reader where we're recommending feeds. You'll see cases where you'll, in iGoogle, you'll basically already put the information in there. Alerts is an example where you keep track of things that are happening in that space. So you're seeing more and more cases where you don't have to ask for something to get it. And I think that's a very important organizing principle on the web. And I think you're right. It's going to drive viral distribution and other things. We are doing some, what I think is really interesting work in that area that I'm not free at this time to go into. But I feel like what you're seeing is a really, really important piece of how communication and interaction is going to happen. And we absolutely have to participate in that.
Okay, we have microphones in the back.
Yeah, question on Google as a content delivery network. How capable are you of replicating or replacing that which Akamai or Limelight produces, and how do you, I guess, feel about peer-to-peer architecture and some of the business models that have evolved around that, and whether or not Google would take advantage of that type of architecture? Thanks.
Well, my first reactions, and I think Alan probably has some thoughts on this too, are that we have already gone down the path of replicating substantial amounts of information in a substantial number of data centers around the world. And we have to do that because you don't want to lose access to our index if you're doing search. You don't want to lose access to your email. If a data center goes away, we don't want you to notice it. We'll notice it, but we don't want you to notice it because we want the data to be replicated and available to you wherever you happen to be and wherever it happens to be. So my sense right now is that the architecture of the data center system is actually stunningly robust. It doesn't mean that it can't be made even more robust with time, but my sense is that we've already had to do much of, and maybe more, of the things than other companies have in order to make sure we've cached information to deliver it a timely way. YouTube is a very good example of a challenge along those lines because there may be 8 hours worth of video coming in per minute, but I'm pretty sure there's more than 8 hours per minute of video going out. And in order to serve up all of that stuff, we need to have things replicated. Alan?
That's exactly right. I mean, your point is very well taken, is that the delivering content to the edges of the network so that you can keep latency down, so you can keep, not deal with the bandwidth issues, all those kinds of things. Those are very important to us. And not only that, there's an efficiency associated with it. If you can do caching on the edge, you'll basically be able to take away a lot of load that you're going to put on other places. You'll also get some advantages in terms of redundancy and other kinds of things. So actually putting things on the edge of the network is a very important part of the way we distribute information. As far as peer-to-peer goes, we do use peer-to-peer in particular places inside the company and particular situations where we think it's appropriate. There are some downsides of peer-to-peer. Obviously, you get a little less control over the quality of service and other kinds of things when you do that. You also tend to depend rather heavily on third-party machines that you don't control, maybe even they don't control them. And also, you can end up in situations where, in the past, I think, a large amount of UW's, computing capacity was being spent on Kazaz or something. So, you do end up with situations where peer-to-peer is not the right thing. But in particular situations, I think it's actually a very good technology for solving a particular problem.
Thank you very much for allowing us to take a little bit of your afternoon. We'll turn this now over again to George Reyes.
Nice job, guys.